Hey guys, on this flipped lesson, we are going to work on guided proofs as they relate to angles, okay? Let's get started with the first one that we see. They are telling us that angle 2 is, the measure of angle 2 is equal to the measure of angle 3, which is already indicated in the diagram. Then they tell us that the measure of angle AXD, so AXD, this angle, is equal to the measure of angle AXC. So this one right here, and I'll use a double arc since the single arc was already taken. They then want us to conclude that that means that angle 1, the measure of angle 1, has to be congruent or has to be equal to the measure of angle 4. Now really this makes sense because if we have a congruent set of congruent blue angles and we subtract out the congruent black angles, that means we should be left with angle 1 and angle 4 being the same measure as well. So let's get started. This first piece of information is just given information. Okay, then they make the claim that the measure of angle AXD is equal to the measure of angle 1 plus the measure of angle 2. So baby angle plus baby angle equals the big angle. This looks like angle addition postulate. Next, they say that the measure of angle AXC is equal to the measure of angle 3 plus the measure of angle 4. This looks like angle addition postulate as well. Okay, next, they make the claim that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 4. Now, I think that they have combined this statement, and this statement. Everywhere they saw AXD, we could replace it with angle 1 and angle 2. Everywhere we see AXC, I can replace it or substitute in the measure of angle 3 and the measure of angle 4. So this looks like substitution property of equality. Okay, next they make the statement that the measure of angle 1 is equal to the measure of angle 3. That's our next given. So now we've stated both. Okay, so everywhere that I see the measure of angle 2, I could replace it with the measure of angle 3. So right here, you're going to see me utilize substitution property. Okay, last step, it looks like they subtracted the measure of angle 3 on both sides. So that would be the subtraction property of equality. Okay, and now my final statement matches what it was asking to prove, so I am done. Let's take a look at the next example. All right, so for this one, they're saying that ray BD bisects angle ABC. Okay, so those two angles must be congruent. Now they're wanting us to conclude that angle ABC must be equal to the measure of angle 1 times 2. So if we double angle 1, it should be equal to the whole angle. Really, this makes sense. It's pretty intuitive because this is being bisected or cut in half. So angle 1 and angle 2 are the exact same measure. But let's formally take the time to prove. So we know that the first step is just to start with some given information. Okay, next we're using the definition of an angle bisector to make a conclusion. Well, if that's being bisected, then angle 1 must be congruent to angle 2 by definition. Okay, if they are congruent, then their measures are equal. So the measure of angle 1 is equal to the measure of angle 2. We always move from congruence to equality whenever we want to manipulate an equation. So you can't manipulate a congruence statement, but you can manipulate an equation. So now they're saying that the measure of angle 1 plus the measure of angle 2 equals the entire angle. So baby angle plus baby angle equals the whole angle. That is angle addition postulate. Okay, next they're wanting us to utilize substitution property in some capacity. So the measure of angle 1 plus the measure of angle what? Well, angle 1 and angle 2 have the same measure, so everywhere I see angle 2, I can replace it with angle 1 using the substitution property of equality. Now they want us to simplify. Well, something plus itself could be represented as 2 times, well, I'll use the multiplication symbol. 2 times the measure of angle 1 is equal to the measure of angle ABC. So again, we were simplifying, or you can always call this combine like terms. Okay? Now, this statement does not exactly match what they're wanting us to prove. We need to swap what's on either side of the equal sign. So we now have the measure of angle ABC is equal to 2 times the measure of angle 1. This is the symmetric property of equality. Again, symmetric, think, swap. Okay, you can swap what's on either side of the equal sign with this property. All right, that's it for your example on angle-guided proofs.